So running a simulation model. We'll start by looking at the model structure. You add components and then you join them together and then you put in the equations. Here we can see the incidence queue. So this is the first line queue, then the second line queue, and then the third line queue. And then if it can't be resolved, it's going to end up as an enhancement or a bug. Work flows into the incident queue through the incidents pipeline, and it flows out through the first line resolve pipeline and the first line escalate pipeline. For the first line resolve pipeline, that is controlled by the incident complexity, the number of first line agents, and the productivity of the first line agents. Inside each object is a formula, and it's these formulas that connect and drive the simulation. And we'll look at one of those now. The level in the incident queue is increased by the incidents coming in, and it is drained by the first line escalation and the first line resolution. Right, we'll now run a simulation. We do that by clicking this button, and what you'll immediately see is that there is a thumbnail on each of the items there indicating its value as the simulation runs. You can use the controls to change the behavior, and I've set them up for convenience on a dashboard. And here's that dashboard now. Now remember, the simulation's running, so if you change the controls, you can observe the effects. So we'll perhaps start off by changing the number of instant arrival rates. You've assumed it's 100, but what happens to your queues if actually it's higher? You can see your queues building, the incident queue, but also your second line queue is also building, but that's less visible. You can also use it for perhaps making management decisions. It may be you want to decide how many agents you need and you're not sure. So you can try varying that number in the simulation and seeing the effects on your incident queues there. Perhaps also you may consider training up your agents to increase their productivity. And so you can evaluate the effects of increasing or improving the productivity of the agents there. Also, perhaps the incidents are more complex than you think, in which case more of them are going to get passed up or escalated to the second line queue. So you can look at the effects of that. Next, we're going to look at Monte Carlo simulations. Now, these simulation models, they've got lots of variables: incident arrival rate, complexity, productivity, and so on. And this means there's tens of thousands of possible combinations. And each combination is going to give you a different output. And it's not possible to run thousands of combinations manually, but you can run a Monte Carlo simulation. We'll do that now. So we'll click here to start the simulation. And what you'll see then is a wizard pops up, and you'll see that everything that's in yellow there, we can use as a variable in the simulation if we want to. Let's now zoom in on the sensitivity setup there. You can see that we're going to set this to 100 simulations, and you can see we've set 4 variables in the Monte Carlo there. You can also see you can set the distribution, and you've got a lot of different options there. We're just going to set it to uniform. Once we're happy with that, we'll move to the next screen, but save first. On this screen, everything you see in green, you can record as an output, but you don't want to record everything because it's taking you a lot of data, or it's taking a lot of space. So just record the things you're interested in, and we're interested here in the size of those queues. So now we'll look at that simulation, and we're looking at the incident queue simulation. So we'll expand this out a bit. And what you can see here is the results at 100%, 95%, and 75 and 50% probability. And so, example, if you see the green, That's showing you there's a 75% chance the queue is going to peak at 1,000 units at about 30 days. This is the output for individual runs. And the final bit we're going to look at is using simulations as serious games for training. Now, training teams is a really important part of preparation, but without a system, it's difficult. However, you can adapt a simulation model to run in game mode and train up teams. So, here we've got that same model with a small addition to it. So, we'll start a game. We set the amount to move. And the turquoise variables, they're the game variables we've set up, and we can change those as the game progresses. So we'll advance the game a few moves, and you can see the results in the queue in the graph, and they're increasing, which is what we're expecting. We'll just increase the number of advanced steps. Now, at some stage you may be looking at these graphs, and your team may make a decision. Actually, we need more second line agents. So you can go in, you can change the number of agents, and then you'll expect your red line there to change. And indeed, yeah, we can see it's increasing less slowly. But perhaps we decide it's not increasing slowly enough, so we add some more agents in. We'll run it through a couple more steps. Yep, and it's slowed further. But perhaps we may come to a conclusion now. Actually, we made a wrong decision a bit earlier. So we'd like to retry that or revisit that. So you can wind the game back, wind the clock backwards, revisit that step, and make a different decision there. So you can train people up very quickly like this. And we can see it's had a big difference there. It's had a big impact. And so in this way, you can use simulations in game mode to train teams, to plan, to train, to try out decisions, all in relative safety and all at fairly low cost.